Hello everyone, we will flash the ADI-IIO image onto the P159 device via SD card boot, followed by a full functional test. First, take your SD card, insert it into a card reader, and connect the reader to your computer. Your computer will recognize the SD card as a USB drive with a specific drive letter. Now open the imaging tool. This step is crucial. Select the drive letter corresponding exactly to the SD card. Choosing the wrong one risks writing data to other disks, so double check. Once confirmed, browse to your image file, select it, and click Write. Hit Yes to confirm, then wait for the burning process to finish. Around 20 minutes. When done, click OK. Close the imaging tool, and safely eject the SD card. Next, connect the SD card to the P159 device. A quick reminder, pay attention to the insertion direction, and push the card into the slot until the latch locks it. This ensures a secure connection. After that, connect the DC power supply, Type-C cable, and Ethernet cable one by one. Use a high-quality hub, or a direct connection F, or port expansion and the original Type-C cable to avoid glitches. With all connections complete, power on the device. Now move to the computer side setup. Ensure the serial port and Ethernet cable are properly plugged in. Open Computer Management, Device Manager, to locate the serial port, COM5 in our example. If missing, install the serial port driver via the provided tool or driver software. The serial port software used for demonstration here is included in the resource package. Once installed, open the serial port tool, select Serial Port Protocol. Choose the correct COM port. Set baud rate to 115,200. Disable all flow control, and click Connect. Wait for print information to finish. Once the terminal interface appears, the serial port setup is done. At this point, we have entered the terminal interface. Next, configure the network port via terminal commands. Set the device's IP to the same segment as your computer. Our current segment is 1, so we'll set the IP to 192.168.1.10. You can choose any address from 1 to 255 based on your needs. After configuring, confirm the IP is indeed 192.168.1.10. Then test the connection with the ping command. I'll ping my computer's IP address. If you get a response, that means the network path is working perfectly. OK, now install the ADI-IIO test software from the provided package. Double-click the installer, accept the license, and click Next to complete installation. Since it's already installed on the computer we're using for the demonstration, we won't reinstall it. Launch the software via shortcut. It will auto-detect the P159 device. If not detected, refresh a few times. Once you see the device information, click Connect. Two windows will appear, the configuration window and the display window. Let's start with the configuration window. Here, you can set the local oscillator frequency. Below that are the ARC settings, bandwidth, sampling rate, and other related options. Then there are the TX settings, followed by ORC settings. We don't use these by default. There's also a DD's single-tone signal setup, with a default frequency of 40 MHz and amplitude of -12 dB, and this feature can be turned off temporarily. At the top of the page, Radio On is enabled by default. If the device isn't running later, make sure this is still turned on. On the right, you'll see two receiving channels, OIO-Q and 1I1Q. Let's check the OI channel to view its time domain values. You'll see the waveform fluctuating. Now switch to the frequency domain. The average value box is set to 10 by default. We use the default window, and the FFT size is 16,384. We usually keep these default settings. Click the Run arrow at the top, then right-click to select a marker point. You'll notice the noise floor is around -70 dB. And there are some environmental frequency points, around 2.4 GHz in our case. You can try adjusting the local oscillator frequency to 4 GHz. And you will be able to see the frequency points around that band. For TX, set a single tone signal. And you'll spot a frequency point at 40 MHz. Right now, we are not using a spectrum analyzer or signal generator. This is a basic test where TX transmits a signal through the air to ARCs. So it's just a rough check. Turn off TX1 and turn on TX2. You'll still receive the signal, but its amplitude is slightly smaller than that of TX1. We can also enable TX2 right here to check its baseline performance metrics. Next, let's connect the spectrum analyzer to check the TX signal output. Here are the steps. First, connect the spectrum analyzer to the device's TX1 port. Make sure to tighten the cable fully. Loose connections will cause inaccurate test results. Once connected, press the Auto button on the spectrum analyzer. This will auto-scan frequencies, and we can check the received signal frequency right away. Next, configure the TX signal transmission parameters on the computer. We'll set the single-tone signal frequency to around 40 MHz, and the signal amplitude to -12 dB. Once the parameters are set, the actual signal power we observe on the spectrum analyzer is approximately 2 dBm. And this is the combined effective gain and attenuation in the TX circuit. That's the complete TX signal test procedure with the spectrum analyzer connected. Next, let's walk through the ARCS test procedure step by step. First, connect the RF signal generator to the RX1 interface of the device. Then configure the signal generator parameters. As the device's local oscillator is currently set to 4 GHz, we'll set the generator's frequency to 3.999 GHz and the output power to -35 dBm. Once the parameters are set, turn on the RF signal generator. Then check the device's signal reception status on the computer. On the computer interface, we can see the device has detected a TX frequency of 3999.07 MHz. This confirms the device has successfully received the RF signal transmitted from the generator. The signal generator's current output power is -35 dBm. Given the built-in gain of the TX module, we can perform gain calibration in the next step by adjusting the relevant parameters. Now, the ADI-IIO full function test demo for our P159 radio board is complete.